the whole point of today is to connect the rational function graphs, which you did in 9.1 and 9.2, to the actual solving you did in grade 11. We did this briefly on 9.1, converting it into out of transformation form and into standard form. So super easy. You guys are like, sure. First thing I want to do is if it's an equal sign, we did this in grade 11. If it's an equal sign, we want to get rid of our denominator. So the common denominator here is what? X plus 2. These all have denominators of 1, correct? Everybody agree with me? Those all have denominators of 1. So before I start doing any math, I need to factor everything, which in this case it's already factored. What's step 2? Step 1 is factor everything. Step 2 is NPVs, non-permissible values. So what's my NPV here? X cannot equal -2, absolutely. Okay, so then what we're going to do is we are going to find our common denominator. Our common denominator is going to be X plus 2. And so this is a lesson from grade 11. Like this is what we're doing in grade 11. So if it feels kind of familiar, you hated it when we were doing it, but now you're going to do it and it's not going to be hard because it's just math. We're going to take our common denominator because it has an equal sign. We're going to multiply by tops only because we want to eliminate the X plus 2 on the bottom. But we have to multiply every term. I'm going to multiply that one by X plus 2 as well. So I have to multiply everything by X plus 2. So this is going to be X times X plus 2 plus 6, because those will cancel each other out. That was the whole purpose of doing this, was to get rid of the denominator. Are we good with that? Like that was the result of multiplying all tops, all term tops, numerators by X plus 2. And that's what we get. Now we're going to go ahead and multiply it through. We're going to simplify. So we're going to have an X squared plus 2X plus 6 minus 5X minus 10 equals 0. And now I'm just going to combine like terms. So it wants the roots. It wants the roots. So what is it asking me to do? Give it some roots. So what is it asking me to do, the question? I need to solve it, right? Like I need to factor that quadratic and I need to solve it out. So hopefully everybody's comfortable with factoring. All right. So we're going to check it against our NPVs. We have to check these answers against our NPVs. Do both answers work? Yeah. And that's where you're going to be checking it against. You're going to reject anything that is an extraneous root. Okay, so I am going, every time I go to Desmos on this, it kicks me out of my video. So I'm going to graph it on my graphing calculator because, oops, somebody's been in my graphing calculator and putting some questionable things. Gotta hate when people use your graphing calculators. Okay, so I'm putting in the same equation. So y equals x plus 6 divided by, I gotta use brackets, x plus 2, close my bracket, minus 5. So that's a little, let me get a better window here for us. Let's go, no, I guess that -5 worked. Let's graph that. Well, that is a funky graph. So as you can see, the result was a quadratic for solving, but my graph definitely doesn't look like a quadratic. Everybody would agree with that? Because we're looking at a rational function here, and we would graph it with transformations. We have asymptotes that we have to take into consideration. So that's why it looks a little bit funkier than the regular parabola. Really though, what we were looking for is we were solving. So if we graph that, if we do a rough graph on this, we got this coming down and going over kind of like that. That's kind of an ugly graph. But what do I notice my x-intercepts are at? Where's this x-intercept? This one would be at -1 and 0, and this one's going to be at 4 and 0. And I can check that in my calculator by using second function calc, and then I go to option 0, and it's asking me if I'm left bound. I'm left bound of this 0, so I'll do that one first, and then I got to move my, and then I'm right of that, and then I hit enter, and then it tells me that that's at 4 and at 0, so it does the calculations for me. So if you do have a graphing calculator, this is something you can do. FYI, they do not put big graphs, the big graphing questions in booklet 1 with your calculator. Your graphs will happen in your non-calculator part. So if you think you need to run out and buy one of these for your provincial exam, it's not going to help you. They design the exam so that the graphing stuff is in booklet 2, and you get booklet 2 when I take your calculator away from you. So please know that this is not going to help you on your provincial exam, but Desmos and graphing calculators do help you with looking at it on your homework, looking at how things relate to each other. So if I want to do that again, so second function calculate, I'm going to do the 0. It's saying, are you left bound? I have to be left bound of the x-intercept that I want to deal with. So yes, I'm left bound now. I'm right bound. And you see those little, you guys can't see them, they're not showing up, but little lines are showing. It say, hey, my x-intercept is somewhere in between these two. I can see them on the calculator, and it tells me it's at -1. So Desmos, graphing calculators, there's lots of graphing calculator apps and stuff like that, are super powerful to help you with your understanding, but they're not going to help you on your final exam. Like, they're not going to help you on that provincial exam. Okay, so what do we know? What's the connection between the roots and the x-intercepts? What do we know? You probably could have answered that question without graphing, right? We know that they are the same. So all we've done is we've taken the algebraic solution in A and we've attached it to the visual in B. So we're taking algebra and we're putting it on a pretty picture. All right. Solve this question graphically. Again, this would be probably something I would do with technology, and then we're gonna verify it algebraically. So the way I would treat it is I would put this in as equation number 1, and I would put that in as equation number 2, and then what would I be looking for? Intersections, not the intercept. The intercept is an axis. The intersection is where the two cross. So I think I'll do it I'll do it for us on this one. So let me go in. I need to put in here, I need to put in the numerator fully in brackets, and I need to put the denominator fully in brackets. If you don't, it will just take that 7 and divide it by 3. And then you won't get that rational function. So we have x squared minus 3x minus 7 bracket divide by bracket 3 minus 2x bracket. And then my next equation is x minus 1. The nice thing about this is it will tell me how many answers I have. So how many answers am I looking for? 2, right? Like we see it crosses, that red line crosses the blue line twice. So we know we're looking for 2. And then again, if I go second function trace, there's option 5, which is intersect, which we can use as well. So this is asking me, is this my first curve? Yes, it is. Is this my second curve? It pops to the red line. Yes, it is. And it gives me an answer, I want to guess. Yep. So the point of intersection, so it's showing this point of intersection is x is equal to, what are we doing? Express the answers in the nearest hundredth. 3.10. 3.10 would be that intersection. Oh, that's a bad, but so that point there is 3.10, and what's my y? 2.10. So that point there is, I have to excuse my graph that it doesn't look like it's at a y of 2, but you get the idea. If I'm going to do this again for the other point, again, option 5, but I got to scroll. I wonder if it will pop over. There we go. I have to put the blinking cursor. I've got to use my left and right toggle arrows. I have to put the cursor closest to that point of intersection that I want. So I want the other one. Enter, enter, enter. And the point of intersection is negative 0.43 and negative 1.43. Running out of room. Do I care about my y values in the solution? I don't. I really don't. Okay, so that's how I would graph it. I'd use technology. I wouldn't spend too much time, but just know that it is powerful. It does show you. I know that I'm going to end up with 2 answers when I solve algebraically. This is the benefit of it. I check a ton of my answers. Like I was just marking the chapter 3 test. On the blue, I had an A value of 1/2, but I used a different factor. You guys used a factor of x plus 1/2, and I used a factor of 2x plus 1. Same thing, like it still solves out to the same thing, but it affects the A value, and I was like, whoa, are these the same graph? So I just popped them both into Desmos to see if they were, and they actually are. I wouldn't have thought it that way, but I went to technology to help me solve that, just to make sure they are the same graph. Okay, so now we're going to do it algebraically. So you need to be comfortable with using your algebra. So step 1 is factor everything. Can I factor that numerator? Can I factor this? Can I factor it easily, I guess maybe is the question. Can I factor that numerator easily? No, I cannot. Okay, so factor everything is done. Non-permissible values. What's my non-permissible value here, folks? 3/2. Or 1.5 if you like. Doesn't matter. I'm okay with either, but you still need to do your non-permissible values. That is a critical part. If they are not listed, you're going to lose a half mark for sure. Okay, step 3. I don't know what step we're on. We're going to find our common denominator. What's our common denominator? You guys are starting to sound like my grade 9s. They don't speak to me. Common denominator, this is over 1, so my common denominator is just the 1 denominator. I'm going to times everything by that common denominator, which is 3 minus 2x and 3 minus 2x. So you have to do it to every term. We treat the numerator like it's one term. Just like I put it in my calculator, I had to use brackets. You're going to treat it like it's the same. These are going to cancel each other out. So I'm going to be left with x squared minus 3x minus 7 equals x minus 1 times 3 minus 2x. So I got some multiplying there to do. Oh, I screwed that up. 3x and then 2x squared. If I don't do it the same way every time, my brain doesn't function great. So I have x squareds right away. So I'm going to, oh, should that be a positive? Plus 2x? Sorry, guys. See, I didn't do it the right way. So that's going to be 5x there. See, look, I just fixed it. I have x squareds right away. I know I'm going to need a quadratic to solve it, so I'm going to bring everything to one side. Factors of 12 that add up to 8. Nothing that I can think of. And right away, do I know I'm going to have nice factors? No. How did I know that? Because of my points of intersection, right? Like, they're not nice. So, like, right away, I know I'm not going to be able to factor this. So I'm going to go to my quadratic. I don't know how many of you still use this and do your ABCs. Oh, I'm in a graph. That's why it's not working. I'm trying to use my calculator. And we'll go to the nearest hundredth again, and you should get both of those answers. The quadratic formula will be on your formula sheet. I don't know how many of you are using your formula sheet for this course that I gave you, but that's the one that you're going to have for your exam. There are no cheat sheets, so all you get is that formula sheet and a blank unit circle. So all your knowledge has to be stored in your brain. Quadratic formulas on there, the arc length formulas on there, the equation of the circles on there, so x squared plus y squared equals 1. And then really the rest of it is trig identities and binomial expansion. So not a lot of formulas on there. Oh, are the log rules on there? I don't think so. I think it's all trig identities. All right. I'm going to get you guys started. I'm going to get you guys started on solving algebraically. I'm going to solve graphically. Okay, so I'll end up drawing a picture. You guys start with your algebra. What's step one? What's step one? Factor everything. Step two, non-permissible values. Step three, common denominator. And I'm going to graph while you guys do that. Oh no, my calculator's running out of battery. Did you put the 2 in your common denominator?
Yeah.
Okay. Easy thing to miss. Did everybody get that for their quadratic? Yeah? And if you go ahead and solve it, and I just want to remind you that when you're doing the quadratic formula, it's all divided by 2a. Like I see a lot of people just put the line under the root sign, and that's technically incorrect. You have to do everything on the numerator first. So you should get 0.75, and you should get negative 2.5. Have you gotten that far in it? Am I rushing you? So again, you're going to check against your NPVs, and this is an NPV. And again, I can't stress it enough. You have to show that the answer is rejected. You can't just assume that I'm going to make that connection. I need to understand that you know that this is a rejected value. You don't have to tell me why, but it's rejected based on the NPVs. And what we would see there is in the actual graph of it, there is a point of discontinuity, and it's weird. On my graph, it doesn't show it, like it shows it as a break in the graph. It's missing that point right there. That's at negative 2.5. And then if I solve for my x-intercept, that happens at 0.75. So the graphing calculator, even if I were to put in a value, if I were to say, okay, I want negative 2.5 in there, it won't show me a y. It will say it doesn't exist. Like even though I'm trying to force it to tell me what the y is, it won't tell me what the y is. So there we are, ladies and gentlemen. So we've rejected one. We know that our rejected is our point of discontinuity. I'm just comparing the solutions. I'm doing part B here. And we know that that's our x-intercept. So the working solution is our x-intercept. Our rejected one is our point of discontinuity. There will be questions on, I've seen questions, I shouldn't say there will be, I can't say that for certain because I don't know what's on the exam, but I have seen them ask questions about what a point of discontinuity is. Like they don't say it in that sort of thing, but you have to know that it is a rejected value, it's a non-permissible value, it is a factor that's been eliminated, like things like that. It will ask you in certain contexts. I've seen it pop up before, so you need to be able to explain it. Okay, last example. Last example of chapter 9. Guys, we're getting there. We're getting there. All right. I screw up this question all the time because free throw is a hard thing to say. In basketball, a player's free throw percentage is given by dividing the total number of successful free throw baskets by the total number of attempts. Makes sense? Mr. Larry has attempted 19 free throws and made 12 of them. Good job, Larry. Good job. So we know that Larry is currently 12 out of 19 successful free throws. Everybody with me so far here? If he is successful on every attempt from now on, how many more free throws does he need to attempt before his free throw percentage is 80? Oh, Larry. Larry and his very good basketball skills. Okay, so free throws. So he's going to be successful. So we know that this is success over attempts. Everybody with me so far here? We want that percentage to be 80%. So we know that we need whatever numerator divided by whatever denominator has to equal 0.8. Everybody with me so far here? Pretty straightforward. So what we're going to do is we're going to define a variable. Let x equal number of future free throws. I would say that creating these equations is one of the harder parts, but I think that's true of any word problem that we do. Remember chapter 3 max-min problems? Those were hard. When we did the rate and ratio problems in chapter 6, those were even more hard. So it's taking that knowledge. So future free throws, we know that our denominator is going to be 19 plus x, right? We know that we're going to take however many he does in the future, 19 plus, if he does another 20, we'd add it on to the 19 for attempts. But the thing here is if he's successful on every attempt, So if he's successful on every attempt, that means our numerator is going to add the same amount as well. Because we're saying he has success on these next baskets that he makes. And we know we want this percentage to be 80. Can we solve? Now we can solve. Now it's no big deal, right? So take what you know and then try to add in the pieces that you don't. So step 1, factor everything. That's already done. Step 2, non-permissible values. That makes sense. Because we're like, but we can't have a future free throw of negative 19. And you're absolutely correct. But in this case, we can't have our denominator equal to 0 either. You could say that x has to be, you could say, you could put a restriction on this where x has to be greater or equal to 0. And why would that restriction work? Can I have a negative free throw? Can I take one away? No. So I'm going to say that x has to be positive. So it's not a non-permissible value, but you're restricting the domain. So x has to be greater than or equal to 0. I could take no free throws. The reason why we need this is because if we get another answer, we'd probably reject it so that the denominator doesn't equal 0. So that's a restriction. And this is what it absolutely can't be, because if we put 19 in here, it's going to give me a 0. Okay, let's go ahead. So step 1, factor everything. Step 2, non-permissible values. Step 3 is common denominator. So my common denominator is 19 plus x. So I'm going to multiply tops only by 19 plus x. Anybody panic when they got a decimal? I did for a second. I panicked a little bit when I first got that decimal there because I'm like, can free throws be halves? Can you do half a free throw? I don't think so. I don't play basketball, but I don't think that's possible. So he needs to do 16 additional successful free throws in order to have a free throw percentage of 80. So again, this is more like a grade 11 question than it is a grade 12 question, but it's creating it from scratch. Good news, there's no trains. There's no trains leaving the station or traveling to and from. It's really going to be the basic algebra that you're doing. So if that makes you feel any better, grade 11 was much harder for this than grade 12. So that, ladies and gentlemen, concludes chapter 9. We are done.